right, let's continue today. All right, so we want to return to our discussion about the definite integral. Yesterday we said finally, I think for the first time yesterday that we put in this box, we said we actually can write this more compactly as using this notation. So I think yesterday was the first time we've actually been using this like squiggly notation. It is actually an S, right? Just so you know, which should remind you of the word sum. So that's why. This is actually Leibniz's notation that he's introducing. Again, he's comes in strong with some nice notation for us. So sum, we like that. In fact, if you look at, we should pull up a picture of the Declaration of Independence. It has those things everywhere. They look like that. Okay. Old school. Yeah, S for sum. Yeah. Yeah. But except in like French, but I think it begins with S in French too. Yeah, it's some. I don't know how you say it. When they get
Français.
Monsieur Jeblan in here. That's how you say some. We've talked about the fact that the definite integral means area, but we have, I don't know if have you noticed, we've been real cautious about that actually. We have said very carefully for a positive function. For a function that looks like this, that is below the x-axis, I want you to think about the Riemann sum that is produced by this kind of picture. What happens when you add up if you really are doing what we've been doing, and that is take the height, take some this is LRAM here, obviously, right? If you take f of 0 and multiply by the width, some width, whatever it is, I don't know, maybe it's 1, who knows. But what will you get? And in all cases here on this particular picture, you'll get negative values, won't you? So when you do the sum, if you kind of obey the way we've been doing it, then we get something negative. If you want to talk about the area, then it's actually like, if you're still asking how much paint do we need to cover this area, then you better report it as positive still, if someone is asking for the area. I just want to kind of caution you about that's something that we need to consider. It's been very, very convenient, hasn't it, recently? Like the only examples, you haven't even noticed, but the only examples we've given you are functions above the x-axis. But maybe you haven't noticed that, but I want you to notice that right now, that's something we've been doing. Go back and look through all the packets and homework problems, and you'll see that it's true. Yeah?
How would we treat something that crosses the
Piecewise, right? Like you have to break it up into pieces if you want to think about area, and which we'll do today. We're going to extensively cover that question that we just asked. So we're thinking about area here, again, to calculate the area versus what the definite integral seems to give. In all cases up until now, those two things haven't even been different, so we haven't even concerned ourselves with the issue. Now, we'll play around with this idea, but we'd also like to play around with it while introducing the following function in your calculator, which will make your life nice. Okay? So let's approximate this integral using the fnint function on your calculator. It's math 9? Maybe? I'm just going off. Okay. Go off memory. It's nice. You've been down in that region before on your calculator, right below end derivative, right? Or above? Below. Okay. So that stands for numerical integration or finite integral or yeah, something like that. Anyway, so again, this isn't going to be you know how it's exactly as useful as end derivatives, right? Like you understand that end derivative was not like the be all and end all of your life, even though when we first introduced it, you're like, sweet, I never have to do math again. But it's not like that actually. Like there are definitely times when it's very useful. When you have a really messy function, you only need the derivative at one point. It is perfect. Same here. This will for any function find a very good approximation of the integral, the definite integral of this function. For example, we'll do here in a second, and I'll show you the syntax. I'll show you the syntax up here in a second. So I think I have it here. Here's what you might type if you have the old firmware on your calculator. Function, comma, independent variable. That is the variable with which you're taking the integral with respect to, x. If that's the variable you're using, x, which is almost always probably what you're using. And then the lower and upper limit of integration. And then that should give you a very, very, very good approximation of the area. See if you get the same thing I did. Feel free to also run numint with whatever, 50 rectangles or 50 triangles or something, and see that this agrees to a couple decimal places, but with a very good approximation. Now again, the similarity with this and nderiv doesn't stop here. Remember nderiv? Do you remember how nderiv actually works and how it was programmed in your calculator? Remember how we described it?
Non-analytical.
Yeah, it's non-analytical. Say more. That doesn't really.
It like just runs it with a very, very high number.
Yeah. So in this case, that's what's happening with high number, or with the definition. Uses the definition of the derivative and does what? Yeah. Nderiv. You remember how it works? Well, I'm thinking of nderiv from first semester. You remember how that works? Yeah.
Just take the number very, very, very close on both sides and then find.
Yeah, I mean, it is actually using the definition of the derivative, but using an h value of like 0.0001, right, or something like that. Very, very close values, but it's still calculating a very, very good secant line, but it's basically a tangent line. So it's an approximation. It's just a really excellent and fast approximation, much easier than you having to type that in yourself. So I just want to dissuade you of like any magic happening here. It's not like your it's not like your calculator knows math. It knows more any calculus really. It was just programmed to do what you've been doing with numint. It just does it really quickly and really accurately. That's all. But it's still a promise. It's still just summing rectangles, really, really thin ones and lots of them. But that is in fact all it's doing. You can give it as a fraction if you like to, of course. Okay. Great. There's the picture. There's the integral. We got 305/3. That's the area from 1 to 6. Maybe that looks like 101 square units. I think that 102 approximately square units. Try this one now also from 0 to 3. X squared minus 9, and tell me what you get. Practice using f and int here. Again, here's the picture if you want. Where's the picture? Somewhere. I'll put up the picture here in a second. But you should think about it too. By the way, at this point, there's not too much need for numint anymore. Really, like if you're going to try and get the value of an integral, you might just use this now. It was instructionally important in our lives, but it's important is waning quickly. What'd you get? Did you get something negative? Yeah, the picture here, of course, is this. So explain why you're getting something negative based on our we already kind of discussed this a little bit today. Go ahead, Nicholas. Yeah, and we're calculating the area from 0 to 3. So, or the integral, rather, from 0 to 3. And so, yeah, what is that area, actually, if you were to report that as an area? We wouldn't probably report that as, yeah, go ahead.
Oh, sorry, I was going to ask a question.
Yeah.
So if the range goes beyond the 0 in that function, then do you just add the positive area and then the negative area?
Yeah, we'll have to, like, if the thing we're asking about is, like, the total area between the curve and the x-axis as it crosses the x-axis, we might have to kind of split it and kind of treat one piece as positive even though it's negative, and then add the part that's already positive and break it up. So, again, we will do that. It's kind of similar to Judith's question from earlier, and you will be exposed to problems of that type before you leave today. Yeah.
Say, like if the line was a velocity equation that because it's negative, that's showing that it's going backwards.
Yeah, I mean, this, you might be thinking this at first. Nicholas, who has quite a bit more experience in life and wisdom than maybe some of us, he realizes maybe because at this point you probably think like this is like an annoyance. This is like not a feature. This is a bug. Like if I want to talk about the area in between this curve and the x-axis, like I'd like to just say that's 18. Like it seems annoying and useless that the answer comes out to be negative 18 from the calculator, right? but he's assuring us, you're assuring us that there might actually be some real world significance to that there, and we'll of course tap into that soon. That we actually most of the time we'll actually prefer that answer, negative 18. But if we're talking about area, it's 18 units squared. Yeah.
If it's like asking for the area from like 0 to 8,
Mm-hmm.
would you like subtract?
Yeah, I think this a couple people have asked this today, and the answer is yeah, we'll have to deal with that, and we will expose you to some problems of that type before you leave today. Like what happens if it's not all below or all above? I mean, I chose these limits of integration very very carefully to not have that happen. It's at least right yet. So anyway, the value of this integral is negative 18 though. But if someone asks you the area question, what is the area here? Well, you never say negative whatever if you're giving an area, right? So how much paint do I need? I need to cover 18 square inches still, or 18 square units. But the integral is negative 18 there. And you saw that on your calculator. You're getting very good at punching buttons on your calculator. Good job. So just to emphasize, here it is, I said it a second ago, and there it is again on the slide. Is that the problem we just did? Okay, 18 is the answer. From 0 to 3? Yeah. Now there are two ways you could do this. I want to emphasize this here. Where's my note here? The two ways you could do this. One way would be to do the calculation you just did, which is this. Wouldn't you agree? You guys punch that into your calculator. If you're finding the area, you could do that and then just put a negative out front so that you get, that'll give you 18 then, won't it? The other way to do it would be to do that. Yeah. Both will give you either one of these commands. If you type this into the calculator or this, will give you a positive 18. So those are good things to say as we think about area. This is the picture of the absolute value of y1. If you graph it on your calculator, you can graph the absolute value of a function on your calculator. Abs is also on the math menu. You can find that. Is that cool? Let me show you one more little calculator trick that I think you'll like. If you get a graph of this, so if you haven't yet put this in y1, go ahead and do that, because I think you'd like this feature on your calc menu as well, on your calculate menu, which is second trace, right? It's just pretty. That's all. It's just pretty. It does nothing more. In fact, you'll never need to use this. There'll never be a time when you are required to use this, but it is pretty. On the calculate menu, you've used lots of these features before, like the value, the 0, the minimum, maximum, intersection. But down here we've got some calculus-y features, right? So it looks like now we understand maybe what both of these are. Number 6 is the derivative at a point, if you want it. It'll give you the derivative at a point. And number 7 is pretty because it'll give you 8. No, I did this here. I did the absolute value of y1. So it'll not only tell you the area, but it'll also shade it nicely. It's pretty. That's what it's kind of pretty. But again, there's no need for it necessarily. You can do this with AppEdit on the home screen too. So, but it is kind of fun. Are you having fun with it yet? Did you try it? I think you now know everything on your calculate menu, what it does and why it's useful and what right? You're done now. I mean, that's it. I mean, that was the learning targets for your life. That was that menu. Let's walk out. Okay. So, again, I probably won't use that a ton in class in front of you, but it's there for you to use on the calculator whenever you like. All right. So go ahead and try this one, and maybe you can do. Well, I don't know. Tell me what you get, and tell me. Some reasoning around why you're getting what you're getting too. This is not just like, I don't know, another random example. I'd like to make a point with this too, and see if you can guess what point I'm trying to make with this, before I make it. Think about the picture as usual. Like, think visually about this. You get it yet?
Yeah, I got it.
I mean, it's also true that that couldn't possibly mean anything other than area is no, that's true. It's like life changing. Yeah, sorry you didn't know that a couple years ago. Alright, here we go. So it doesn't take long. Thank you guys. It doesn't take long to enter these in your calculator. When you do the first integral, did you get 0? Okay. So first of all, explain. Someone raise your hand and explain what's going on there. Kanal.
The integral under the x-axis and above it are equal.
Right. We have like, in fact, maybe can you suggest an even more general principle that goes along with that? Like what's going on there, and like we're as mathematicians we're generalizers, right? Like we want to like say the most general things possible and then hopefully prove them true. Maybe
Odd functions have that behavior.
Okay. You want to say it your way too? Say something like that. Maybe you can make it more precise though. If f is an odd function, like let's actually state the conjecture you have.
If f is an odd function, the integral on 0 to infinity will be equal to the integral of the area under, the negative infinity to 0.
You want to clean that up at all? I felt like there were some issues with that. Also, just keep in mind, like I don't necessarily want to take the integral all the way from 0 to infinity. And also keep in mind that I think they're not equal. Okay? Yeah. Formalize.
Any n, if f of x is an odd function, then the integral from minus n to n along f of x dx is going to be 0.
Okay.
The area
All right, but the area, yeah, no, we haven't, yeah, what's the area? Let's do that too. 2 times 0 to n?
Yeah.
All right, so I think everything that was said that needed to be said was just said. So there's an interesting observation to make there. We also might want to make some claims about even functions too. Okay, so, all right. So yeah, what do you get? You get 0 for this. There's the picture, by the way, right? And then the area, though. Now, how'd you actually compute this on your calculator? Because obviously you can't just type in the integral because that gave us 0. So what did you type in, Matthew?
I put in 2 times the integral on the
Using
from 0 to 5 and sin x dx. So that way it gets both on the right and the left. And since
yeah, and
it's
what does
area,
this come out to, by the way? What was that?
2 times 2.
This was 2,
Yes.
so it's 4. Is that the answer? So it's really actually, I mean, it's kind of startling that the area under sine is this area right here is like 2. Is that right?
Yeah.
Who knew? That's really that's surprisingly clean. It makes me want to like ask more mathematical questions. That's what it makes me want to do, right? Like that can't be a coincidence. There must be a meaning, a pattern, something to explain. Belinda has a question. Or yeah, what's the other way to do this? Or the integral from say what you say. Right? Perfectly fine also, yes? One more way, too, if you like. This is probably not the best way, but I just wanted to say it though. Yeah? Do you agree? You could actually do 2 separate integrals and make the first one the opposite of what it comes out to be from the picture here. But that requires that you kind of know, where that 0 is, where to break it apart, Okay. So I think we're starting to ask the question that Judah and Albert and Belinda asked earlier, and that's like, what happens when we want to ask about the area when we have parts that are above and below the x-axis? So we've just started to have that discussion. Let's have it again with this picture, where I've not given you the rule for this function. I have 2 questions that go along with this picture. So first, what do you think? Now this is just a by feel one here. But what do you think? Do you think the integral from all the way from A to D, what do you think? Is that positive or negative? It is a gut feeling thing. There's no function to actually work with here to verify. There is actually some function because I obviously reproduced this diagram somehow, so I don't remember what the function is though. No, I actually did put a function in. I don't think you could draw that as well as as actually plugging in I think I plugged in a cubic or something. To create that picture. Yeah, I think it's what you said. What was the vote? Yeah, maybe negative. It's possible they're equal. Yeah. And I guess my thought is like this area, you know, if this like jumped into the pool and this area, if it jumped into the pool, like I don't know, like it might be almost the same size as that area. But I think it feels like less. That's just a by feel question. So I don't feel like explaining, but it's negative probably. So go ahead on the second part there. I mean, you guys can write down what you just said there, right? You could say that the area above the x-axis appears to be smaller than the area below the x-axis. All right, so again, maybe I could insist that you do both. One easy way to write an expression for the area, the actual area, that is, what is the total area of these, if we treat them all as positive area and we want to like actually paint all this region, what is that area? One way to do it obviously would be to do the integral from A to D of the absolute value of whatever f is. But I'd like you to write it without it. So go ahead and try that here, but let's give everyone a second to do it. Yeah, like it says, without absolute value, write an expression for the area between f and the x-axis. That is, treat them all as positive, right? All the pieces. You ready? All right.
Did you just write the f of x as negative f of x for the BC section?
Yeah, for the BC section.
Yeah, just for that.
That's what you should get. That's what you should get. All right, does everyone have their answer? I don't want to give a spoiler or something before you thought about it. By the way, keep in mind that, so one way to do it, like we said, is to do the integral from A to D of f of x and use the absolute value around that instead. Tell me why, because I'll see people do this. I've seen people do this. Tell me why this is not sufficient. You get integral from A to D of f of x dx. Yeah. Are you explaining? Yeah. No, you're just waving. No, go ahead. I mean, I'd love to hear it. What?
Because you're adding them together, and then you're getting that sort of
So yeah, like what would happen in this case, for example?
You got a negative number, then you get the absolute.
But that seems like it fixes it, doesn't it? Like we got a negative answer, it turns it to positive, so that seems like it's okay.
That's
It's not how it works. Imagine you did that with the sine function one we just did a second ago. What if we took the integral and then afterward we're like, oh, my bad, forgot to take the absolute value. Let's just do it afterward. Okay, well we did it and we got 0. Taking the absolute value afterward doesn't seem to do the trick, does it? So yeah, and same thing here. I mean, you're gonna get some very small value, maybe negative, and like just making it positive is not gonna do the trick, right? All right, I'm ready finally to have someone actually write out this without absolute value. Bhavesh, you seem excited about this. Go ahead. Well, I don't want you to volunteer then. I want someone else who's excited about it. Oh, you got it? Okay. Okay. All right. Do you guys agree with that? Great. All right. So I hope you're aware of this discussion now. You know, both these valid ways of thinking about this and this invalid way of thinking about it, and also realizing that if there comes a time where you need to do this, say without a calculator, so you don't have access to the absolute value function, whatever, it may be required that you break it up this way. There could come a time when you need to think about this, which means for a function, in this picture it's nice because we can just call them all A, B, C, and D. A, B, and C in particular are interesting to me. But if I actually gave you the function on paper, what would you have to do? If you were to, yeah, you'd actually have to know the zeros of the function in order to do that. So it's possible that you'll need to find the zeros of the function before you do this. It's been nice so far because I've always provided you the picture, you know, and that hasn't been a question in our mind, but I just want to warn you that that's something that can happen. All right, there's another worksheet for homework tonight, and you have a few minutes to get started. This time there is stuff printed on the back as well.
Yeah, actually, no, I'm not gonna say too much about this. I'm gonna get
There are other people who are going to